Next, I'm going to hand over to my colleague Cosmin, who's going to talk about how we optimize video delivery using the visual quality metrics. Thank you.
Hi, my name is Cosmin, and I've been at Facebook for a little over 1.5 years, and I work on the media algorithms team focusing on optimizing video quality at scale. And today I'm going to talk to you about optimizing video delivery using visual quality metrics. Next slide, please. So why would we want to limit playback options and not play the maximum possible quality, particularly on cellular networks, if we want to optimize quality? Well, there's several different reasons. One very common reason is to conserve data on metered connections. While some users may have effectively unlimited cellular data, most users are on limited data budgets, and we have to make sure that we maximize their enjoyment of that data on a, say, per gigabyte basis. That's a reason to do something like this on a year-round basis. In addition to that, we also have unusual situations where we have to react to, for example, submarine fiber cuts or other emergencies that lead to temporary either surge in demand or a loss in capacity. And an example of that was earlier this year during the early days of the COVID crisis, when suddenly large amounts of users were suddenly spending a lot more time online and watching a lot of online video, which was putting a large strain on the ability of networks to handle it, and perhaps leading to a loss of ability to use the network for something more important, such as video conferencing, suddenly working remotely, etc. So that was a time where we needed to react and essentially limit the qualities that we play in order to reduce demand on the network and protect the network for more critical uses. Also, for our own reasons, we may want to protect the non-video traffic in an emergency for Facebook itself, so that people can use the application to be able to communicate with their friends and family, and maybe watch a little bit less video or spend a little bit less data on the video that they watch, so that we can protect that traffic. And then lastly, in some situations, we may want to improve the quality of experience beyond the limit of the client-side adaptive bitrate algorithm, where we notice in certain situations we may want to nudge it towards a particular end of the spectrum in order to maximize that utility. And this is something that may change over time as the client-side algorithms become smarter and more able to rapidly deal with changing network conditions. Next slide, please. So now that we established why we may want to limit the qualities we play, let's look at some options for how we can decide where to put those limits. A very common way to do this is to do it based on, say, resolution. So we may want to limit playback to no higher than 720p or 480p, 360p, etc. It's a very common way to look at it. Another way to look at it is to do it based on bitrate. So we can say draw a line at 1 megabit or 500 kilobits, etc., and pick the limits that way. But really, the way I want to talk to you about today that we found works very well in practice is to do it based on the quality of the video. And this is something that ends up driving more optimal ways of doing it. Next slide, please. So in theory, we can change between bitrate and quality somewhat interchangeably. For a given video at a specific point, for a given amount of bits, we can find the quality, and we can express the same limit as a quality limit or a bitrate limit, and it doesn't really matter. This is in theory. In practice, we'll see on the next slide. There's a wide variety of videos, and at the exact same bitrate, the quality may vary somewhat widely. So here's an example of 2 different videos and a few different points, and we can see that at the same bitrate, the blue video above and the orange video below have wildly different qualities. And we can imagine the graph goes from lowest possible quality to highest possible quality. We see the blue is looking quite good, while the orange video is on the quite poor end of the spectrum at the exact same bitrate. Next slide, please. So here's an example at 400 kilobits using a VP9 encode across a wide variety of videos. We can see the variation in quality score on a scale of 0 to 100. And this is due to the wide variety of content and viewing conditions, which leads to a large variance in quality at the same bitrate in practice. And this is the situation that we want to avoid. Next slide, please. So if we think of the quality on a scale of 0 to 100, there's some 3 distinct areas within that scale that I think are important to keep in mind. There's a range where the quality itself is not annoying. The user can watch the video and the quality kind of gets out of the way and they don't really notice it and they can just enjoy the content. There's a part of the spectrum where the quality is a little bit annoying, but it's acceptable. The user can continue to watch. They'll notice the occasional slight impairments, but it's not so bad that they would stop watching. And the last is the not acceptable end of the spectrum, where the quality is so bad that the user would rather stop watching and maybe go do something else. So we want to avoid situations where we nudge the user in the unacceptable range of the spectrum, and we want to keep it, at worst in the annoying but acceptable range. And that's why it's important to keep the quality within a tighter bound rather than allowing it to vary all over the scale. Next slide, please. So here's how we can define those quality limits in practice. We can define some threshold at the max. So we can say this is the maximum quality, and anything above this quality we will not play. And this can be in the not acceptable or the not annoying acceptable end of the spectrum. We can also then define a minimum quality threshold where the unacceptable range starts. So we can say we want to definitely make sure that we play something above unacceptable. And then we can use some upper and lower bound bitrate safeguards to ensure that we don't go either way too high in the quest to avoid low quality, and we don't go way too low in the quest to avoid too high of a quality. And this is primarily necessary because the underlying metrics that we use themselves are not 100% reliable, and they may have situations where for certain content, they may be unusually low or they may be unusually high. So in order to avoid situations where we cannot trust the metric itself, we define some bitrate safeguards to avoid this and keep the quality of experience somewhat reasonable even in those extreme conditions. And we can set different limits for intentional viewing and for autoplay as an example. So if we know that the user is really engaging with this content, we may choose to use higher limits. And if we think the intention to watch the video is somewhat more marginal, then we can use perhaps lower limits as an example. Next slide, please. So here's the example with the same videos before using these 4 limits that I mentioned earlier, and I'll explain the lines in a second. So we can look at the yellow line being the higher upper quality threshold, the green line being the low quality threshold, and then the blue line on the left being the low bitrate safeguard, and the red line on the right being the high bitrate safeguard. So we want to make sure that we place something below the yellow, ideally, but above the green. And above the green is critical, such that if there's nothing below yellow, we still want to make sure we're above green, even if we have to violate the upper constraint, as we see in both of these cases. And we want to place something to the right of the blue line and to the left of the red line. So in practice, for these specific videos, this ends up being these 2 points. And we see that whereas before there was a wide variation between the 2 contents, now they're a little bit closer quality-wise. The blue is playing a little bit lower, and the orange video, which was more difficult, is getting a higher bitrate allowance and getting a slightly better quality. Those 2 are now closer together, and therefore there's a much tighter spread on the variation in quality. Next slide, please. So in review, some of the benefits of using MOS or quality-based limits instead of bitrate or resolution limits is that we can result in a more consistent user experience. It will reduce the incidence of unacceptable quality and can deliver in practice equivalent data savings to the other methods while having much better user experience. And it's particularly good as a year-round way of optimizing usage on metered network connections and ensuring that users get consistent quality for less bits. Next slide, please. So we looked today at a few different options. We talked briefly about resolution, bitrate, but really quality as being the primary way of doing this. And next, we're going to consider looking at slope, perhaps. We can use slope to perhaps determine points of diminishing returns of quality per additional bits. So that's something we're going to look into over the coming year. And who knows, maybe next year, we'll talk more about that. Next slide. Thank you so much. Again, I'm Cosmas Tajirian, and next, I'll hand it over to my colleague Visala to talk about hardware acceleration for energy-efficient video transcoding.